So Jagadish, Sainath, and Ramalakshmi, are you guys are practicing or are you, following the statology?
Yes, sir.
Is there any questions till now what we had discussed in that statology and the statistics?
No, sir.
No questions. What about Sainath?
Clear, sir.
Okay. See, so now I think in the last class we talked about box plot, right? Let's finish it visualization techniques. What are the different other techniques we have it, like, for with help of the visualization we can easily understood the data, right? Okay, from that one we gone through that box plot. Sainath, do you know what exactly the box plot is doing? Sainath, what exactly the box plot is doing?
Sir,
What box plot is doing? What is the importance of the box plot? Jagdish, what is the importance of the box plot? What about
creating a summary data to display.
okay, displaying the 5 summary data?
Oh, sorry.
Yeah. So 5 summary in the sense, what things could be there, Ramalakshmi, in the 5 summary?
Like a chart, bar graph, MS.
No, my question is then that box plot which is describing about 5 summary elements, right? Which is displaying
Yes,
the
sir.
5 elements. What are those 5 elements?
Minimum first quartile, median third quartile, maximum.
Yes, that's correct. So min value, max value, median value, and first quartile and third quartile, right?
Yes, sir.
So
Third quartile as well, right? The third.
yes, third quartile, first quartile and third
Quartile.
quartile.
Yeah,
First
quartile.
quartile, third quartile, median value, and min and max values.
Okay, got it.
So yes, so even the data could be anything. It may be 1,000 records or 1 crore record, 1 lakh of record. Doesn't matter it. Okay, that entire distribution we can describe with 5 elements. Okay, that 5 elements also we can display in the graph that we are calling it's a box plot. Clear? Now we'll talk about the stem and leaf plot. Stem and leaf plot, what exactly which is doing? Uh, let's see this example. So it was very simple thing actually. Stem and leaf. Stem and leaf. See, the first element is the one, right? Okay. Yeah, the first element is the one, right? And the first element is the one, right? Okay. So that one, and in the 1 to 20, 1 to 10 to 19, we have the 3 elements are there: 12, 14, and 18. So this 12 and 1 and 2, 12 and 1 and 4, it's a 14. 1 and 8, it's a 18, right? When coming to the 2, I mean, so the first element is the 2, right? And the first element is 2, and the second element is 2, and third element is also 2, and the fourth element, I mean, this element also 2, and this element is also 2, this element is also 3, this element is 5, right? But every first element is the 2, 2, 2, and a 2, right? So this is the 4 elements. I mean, even this one also. Total we have the in the 20 series we have the 6 elements are there. Okay, the 6 elements. So the stem I'm making is the 2, and the first element is 2, first element is 2, and the first element is here 3, first element is 5, first element is 5, and first element is 8, right? How we are getting these values? Are you going to understood or not?
Yes, sir.
The pattern we are generating. So when coming to the 4th series, in a 3 series you don't have any elements, so that nothing will be there. Okay, but in case of 4th series, we have 3 elements are there, so that 45, 47, and 48. Okay, the first the last element we can make it as the stem, and corresponding leaves, these are the leaves for that, stem and leaf. So this is the way, whatever the data we have it, that particular data we can display with this particular graph format, that we are calling it say stem and leaf. Okay, step number 1 is split each value in the data set into the stem and leaf. Okay, here the stem of each value, the first digit, so 1 1 1, and 2 2 2 2 2 2 4 4 4, these are the stem values. Leaf in the sense, the each value of the second digit, 2 4 8 2 2 2 3 4 5 5, and these are the values we are calling it a leaf. Okay, step number 2 is to make the plot, place the stem value in a vertical axis, and leaf values we can make it as the horizontal axis. Okay, so this is the example of the stem and leaf method. Is there any question regarding about stem and leaf? It may be interview question, what stem and leaf plot is doing. So which is splitting your data into stem and leaf. Stems values we can make the plot in a vertically, and the leaves values we can make it is horizontally. Okay, clear? So corresponding Python code also we can see. So if you click on this one, you might be getting some code here. This is the example of, this is the stem graphic is the library. This is the library you need to be installed in your okay, Jupyter notebook. Let's open Anaconda Navigator. Even box plot also we can display, guys. Nothing much. Just launch it. Desktop. Use stats. Okay. You can see this is the box plot. With help of the Python code also we can generate the box plot, right? So first of all, these are the libraries, matplotlib and numpy is the libraries of the Python. So these libraries you need to go for import it. After import is done, then you have to create the data. I'm creating some random data. Okay, approximately 200 elements I'm generating it. Okay, and so I would like to go for plot it. Random or normal, 100 20 200, and this is your figure size, and I'm just go through the box plot. This is direct method, we have it box plot, and you're giving the data, and it could be displaying the box plot for us. So this is box plot, right? So here we have some values or less than the so this values, this is your min value, this is your max value, but this is the quartile, this is your q4, this is your q3, this is your q2, this is your q1, this is your q0. Okay, the values what we have it's outside of this particular thing, those are the outliers. And this line above, what dots we are able to see, those things we can call it as no outliers. Now within the same graph we can display the multiple box plots. Within the same figure I would like to go for display the all the box plots. I am creating some elements here. This is my data 1, this is my data 2, this is my data 3, this is my data 4. With the help of this 4 series, I am creating the one big series. Okay, so this is data 1, data 2, data 3, data 4, right? So this all 4 elements I am giving as the input of the box plot, then automatically it will be generating the box plot for 4 elements or 4 data things. Just a minute guys, I'm getting, can you note this code? Can you please execute this code in your laptop? Done. Hello Jagadish, Sainath, Ramalakshmi, Kunal, have you done this particular portion
Over,
of it?
over, sir.
Okay, so I just want to be plot the multiple graphs in the same plot, okay, or multiple box plot in the same graph. That also we will do it with the help of this concept. Even same box plot method only. We are giving all series as the input of single input of the box plot. Now a stem graphic. This is the library. So this is the library. Might it was not available in my local computer, so that I have to be go for install it. So with the help of this command, I can install the stem graphic. If you're not installed this one, maybe you can't able to use the stem graphic method. Okay, so here I have a data something like this. This is my X data, and so now what I can do, X. What? Okay, see. So this is the library. This library will help you to implementing or to display the stem plot graph. Okay, this library I imported. This is my data. Okay, this data I am giving as input for the stem graphic dot stem graphic method. This is the method and which is receiving the input of your data, and so and it was creating the figure and the X, right? And I would like to be go for plot this show by the time. So here we have okay 6 series. Okay, the 6 series, is the graph is correct or not? In a 3 series, how many elements we have it? 3 elements, right? 3, 2, 3, 4, 3, 5. Okay, So 1 to 4, it will be first line. 5 to 9, it was in second line. Okay, so total we have the, so here we have a 2 elements, and 2 plus 1, it's a 3. As of now, it's a 3 elements. Now in a 4 series, we have the 4 elements are there. But in 1 to 4, we have only 2. So that 3 plus 2, 3 plus 2, 5. Okay, and after the 4, 5, 5 to 9, we have only 2 elements, 6 comma 7. So that 5 plus 2, it could be the 7. And then in a 5 series, we have one, in a below 4 or below 5, we have the 2 to 3 is there. So that so 7 plus 3, it could be the 10. And after the 5, we have only one element is there. So that 5 plus 1, it's a 6, sorry, 10 plus 1, it's 11. In a 6 series, we have a 2 elements are there. So that 11 plus 2, it could be 13. So total we have a 13 elements are there, right? I hope what exactly these elements are. It's a cumulative distribution. Okay, and this is your stem and leaf graph. Stem and leaf graph, which is splitting your data into the stem and leaf format. Clear? Any questions regarding about this one?
Ranjan, sorry, this is Arbindo.
Yep.
I'm a little late coming to the class.
No
Can you
problem.
just review it one more time?
Yeah, nothing else. See, just here we have a data. So this data, I would like to visualize with the stem and leaf plot. Stem and leaf plot, what exactly which is doing? It was splitting your data into stem and leaves format. Stem values are the first digit, 3, 3, 3, 4, 4, 4, 4, 5, 5, 5, 5, 6, 6. These are the digits of the stem digits. These stem digits I have to display vertically. Okay, so 3 right, 4 right, 5 right, 6 right. Only 4 stem elements are there. Okay, and a leaf or leaves, whatever it is. So the second digit, 2, 2, 5, 1, 4, 6, 7, 2, 2, 3, 6, 1, and 1 are the leaves. These leaves values we have to display horizontally. Okay, in a 3 series, in a 30 series, we have the 3 elements are there. Okay, 32, 34, and 35. And in a 4 series, we have the 4 elements are there. And 40 series, we have the 4 elements are there. 41, 44, 46, 47. Okay, in a 5 series, we have with 3 elements, 4 elements are there again. So 52, 52, 53, and 56. In a 6 series, we have the 2 elements, 61, 62 only. But some values are this horizontal line, but some values are second horizontal line. That means first horizontal line, it maximum having the 0 to 4 on 0 to 4 only. Okay, and second horizontal line, which is having the 5 to 9. Here 1 to 0 to 4 and 5 to 9, 0 to 4 and 5 to 9, 0 to 9, 0 to 4 and 5 to 9 actually. Okay, so this is the way we have the two horizontal lines. Now this is the things what it exactly which is showing. In the first, which is started with the 2 elements, and second we have only one element is there, 2 plus 1, 3. And in a third horizontal line, we have 3 elements are there, sorry, 2 elements are there, 3 plus 2, 5. In the fourth horizontal line, we have 2 elements are there, 5 plus 2, 7. In a fifth horizontal line, we have 3 elements are there. So that 7 plus 3, 10. In a next horizontal line, we have only one element, so 10 plus 1, 11. And next horizontal line, we have 2 elements are there, so 11 plus 2, it's a 13. So this things which is showing me like cumulative thing, sum of the elements. Okay, total we have a 13 elements are there, and this horizontal things are leaves and vertical things are the stems. Clear now?
Sir, actually, how it is 0 to 4, 5 to 9, like how
Automatically
you
it
took
can
it?
be generating this graph. You're not displaying manually. Okay, you're just giving
Okay,
this data. You're just giving this data
okay,
to this particular function, and which is generating this particular plot. Clear?
okay, sir.
But how this particular plot is working in the backend, in the sense, whatever I explained, that logic is implemented. Clear? Okay. So that's exactly the stem and leaf. So this stem and leaf method, if you want to be execute, first of all, you have a library. This library you need to be installed in your local computer. Then we have to import that library, and we can have the stem underscore graphic method. And for this particular method, you just providing the data, automatically it can be generated. Clear? Yes. That's about the stem and leaf is doing.
So this stem graph library, where is it, like an open source thing where you can?
Yes, of course, it's an open source thing which is available in online. Okay, you can use pip install that stem leaf graphic stem graphic library. So automatically it can be installed in your local machine
Okay.
from internet. So that command is simple command that you can execute through or your command line prompt, or else in a Jupyter notebook. If you want to be execute, we can use this command. Just we can start with this symbol. Even Jupyter also we can able to go for install the libraries, but pip install, this is the common thing. But when we are using this symbol, which means that which is selecting your operating system from the Jupyter. So this is the command which is installing on your OS. Okay.
Yeah.
Yep. So this is the way you can go ahead with the stem and leaf. We don't have any default library in our Python, so that make sure that some libraries might available, some libraries might not available in our standard Python, so that we have to be install some third-party libraries. Okay, it could be the some third-party library, but it could be open source. You don't need to pay anything. Now scatter plot, I think scatter plot, it will giving the display the relationship. Okay, it is used to display the relationship between the two variables. Previously in a box plot or stem and leaf, which is the univariate in the sense we have only one variable and you're displaying that variable data only. But now scatter plot, what exactly which is doing, when we have a two variables are there, I want to give the relationship between those two things, then we can have the scatter plot. Okay, like here, suppose we have the following data set. It was showing me weight and height of players on the basketball. Okay, this is the height of one particular person and the corresponding weight. Okay, your height is 72 and weight is 190, and here the height is 75 and weight is 200. Just here the common thing is, if in case height is increases, automatically the weight also can increase, right? That means here the weight and height are correlated, or which is having the relation with a positive. Okay, if height is increases, weight also can increase. So that's a relationship is giving actually two variables in the data set, height and weight. To make the box plot, we'll place the height in x-axis and weight in the y-axis. In each player in the represent in the dot scatter plot actually this time. So this is your height and weight. Here, if height is increases and weight also can increase, right? So that's a graph is showing. Okay, scatter plot help us to see the relationship between the two variables. In this case, we can see the height and weight have positive relationship. Of course, right? If height is increases, weight is decreases, that means it's a negative relationship. If height is increases, weight is increases, that means it's a positive relationship. Even if it is height is increases but weight is not it is not changing anymore, which means that it's a no relationship between those two things. Okay. I hope you clear, right? Strong positive relationship in the sense, if height is increases, if x variable is increases, y variable also can increase automatically. Weak positive relation in the sense it was increases, but not exactly this line. See here, everything it could be in a same line. So little bit of variation is there. But when comes to here, your x-axis is increases, y also can increases, but with little more distribution. Okay, no relationship in the sense even x is increases, y is increases. It is not depending. So x is not depending on the y. That situation it was giving the no relationship. Okay, no positive and no negative. Strong negative relationship in the sense if x is increases, y could be decreases with a strongly in the same line. And weak negative relationship in the sense here x is increases, y could be decreases, but with a little, not not strongly, actually little of more distribution. Here the difference between the each and every point it could be little more, but when comes to here it will be very close. Okay, so that's exactly the scatter plot is doing. Any questions regarding about scatter plot?
So the variance, right? I mean, can it help detect patterns also within the data? For example, you're
Of
trying
course,
to look
this
at,
is a pattern, right? So this is
yeah,
scatter plot, which is just giving the relationship between two things, how both are correlated, positively or negatively. If it is positively, strongly positively, or negatively positively. Okay, a strong, so weakly positive or weak positive or weak negative. That kind of relationship we can see with help of the scatter plot. So if we can see, go through the line plot also. With help of the line plot we can see the lines. Okay, clear, right? So this,
yeah, but the inference you have to draw what kind of a relationship they have is just looking at the plot, right? It doesn't
yes,
give you as an output.
it's
Is it
not giving
a
any kind of
positive?
output, but just showing me, it will showing
Yeah,
me a graph
it's just
actually.
a
So
plot.
from
Yeah.
this graph we should understand. So
Okay.
let us consider you're the manager of one particular product, I mean sales company. Okay, so you should you should get the relationship between the sales versus sales versus and your profit. Okay, your sales is decreases, your profit also can decrease or not? Yes or no? Just
Yeah.
imagine yourself.
Number standpoint. Yeah.
Yeah, just think like you're the manager. Okay, so I'm just taking the sales is my x-axis. Okay, this is your my profit. Some situation if sales is more but your profit could not be more, some situation maybe you given a discount is more, right?
Yeah.
That time your profit it's not much high. For example, there is no discount and there is no bargaining, and the cost also it's very high, and the margin of the profit also very high. Okay, the time if your sales is increases, your profit also can increase with this with the without any distribution, right? Okay, some situation what happens, your sales is increased but your profit could be little less. That situation maybe with little of this kind of lines you might be get it right. Your sales is increased, but your profit it is not increased. Some situations maybe there is a lot of reasons, maybe you given a discount is very high. Okay, maybe you're not fixed the constant price. Okay, maybe bargaining is going on in your company. Okay, and the margin of the profit could be very less, so because of that one you're not achieving the more profit, right? So that's things we can understood actually with help of this particular scatter plots. And we have a line plot, and the line plot which is showing me this same dot lines, it will be connecting with the line. Okay, instead of connecting with the line you can display with the circles that we are calling it scatter. Here line plot and scatter plot are doing the same thing, but the line plot which is giving the output in a line graph, scatter plot which is giving the output in the dots. Clear? But it's just giving the relationship, nothing much.
Yeah. Yeah. Got it.
Okay, And relative frequency histogram, in the sense histogram, it will help you distribution of your data. Okay, so for example, item price, it was under to $10, sorry, $1 to $10, there is a 20 items are there, let us consider. So item price, in between the 11 to 20, we have 21 elements are there, 21 products are there. In between 21 to 30 price, there are no 13 items are there. In between 30 to 31 to 40, there are 8 items are there. Okay, in between 40 to 50 item price, there are 4 items are there. So this is your frequency table. So this is the way you can give the count of the, okay, so frequency of the range or frequency of one particular element, that we can say that it's a frequency table. Okay, it will be looking something like this. This is the frequency table. You can display in the histogram. Histogram in the sense bar plots, nothing else, it's a bar plots. Okay, so here you will be getting the bars over here, and so this is the bars. Item price you're taking an x-axis, and frequency you're taking as an y-axis, and we are giving the 1 to 10. There are 20 items are there, right? So we are getting the one bar here. In between the 11 to 20, there are 21 items are there, and in between the 21 to 30, there are 15 or 17 items are there. In between 31 to 40, there are 7 items are there. 41 to 50, there are maybe 4 items are there. Okay, so this is the way you can display the bars on the table or plot, so that we are calling it a frequency table or histogram. Okay, this is the frequency table. This table, when we are converting into the graph, that we are calling it a histogram. Okay, so relative frequency, in the sense we are giving the probability of each and everything. When you do the sum of these all things, you will be getting the one. So total we have the 66 items are there, right? So 20 by 66, 21 by 66, 13 by 20, 66, and 4 by 66. So this is your probability of each and everything. Okay, this is your probability. Okay. So the probability relative frequency histogram is the maximum, it could be the 1, 0 to 1. So the range is 0 to 1. But here it's a numbers, it's a count. It's your frequency. That frequency, when you're converting into the probability, you will be getting the 0 to 1 only. When you do the sum of all things, you will be getting the maximum is 1. Okay, when to use the relative frequency? Okay, a frequency histogram can be useful when you are interested in raw data values. For example, shop might will go set in the 10 items, the range. So maybe if your item could be very large, that situations, no, the graph, it could be very tough to display in the single plot, so that we can go through the frequency table or relative frequency table, everything we can display in the 0 to 1. Clear? Okay, so this relative frequency we can create it in a Python code as well. Okay, so nothing else. Here we have a matplotlib, is the one library. NumPy is the creating the numerical Python, and we are taking the creating the figure over here, and this is your subplot 111, in the sense we are going to be displaying only one graph, and in the row and column, and you are displaying only one plot, and you're giving the data. So you have already some data. Okay, so the data you're giving as an input, and edge color is a black, and so no, and once like data line by this is your frequency thing you're displaying. Okay, this is your frequency, this is your
So
frequency
one
table.
question on the import statement, right? What's the
Yes,
difference in the two imports, right? Are they, I mean, is there a specific library set that you're importing? What is the difference in the library set that you're importing from NumPy and Matplotlib? I mean, why are you importing two essentially is what my
see
question is.
your numpy and matplotlib, this is the matplotlib, it will help you visualization with Python.
Oh, okay. It's actually plotting that. Okay,
Yes,
this is the
it's actually
visualization
plotting.
library.
Okay, so here importing matplotlib.pyplot as a plt, right? So every time you're plotting plt.figure. Okay, and so we are with help of the plt.figure, we are creating the one figure, and you're giving axes, you're displaying only one graph, 1 comma 1 1 1 1 in the sense, and the total figure, it could be only one. Okay, and we have the row one, and we have the column one, and we have only one figure. Okay, and for example, if we have the two figures over here, okay, this is 1 1, this is 2. Okay, For example, we have the 4 figures are there, 2 rows and 2 columns, right? So this is one row and this is second row. This is column 1 and this is column 2. This is figure 1, this is figure 2, and this is again figure 1 and this is again figure 2. Okay, clear? So
Yeah, that's clear.
one
What
in
about
this
the other
case,
one? Where are you using the NumPy?
one I will tell you, 1 1 1. This is 1 1 2. This is the graph. We can say that it's a 2 and column 1, and this is your figure 1. Okay, and this is about, this is your figure 2, so column 2 and row 2, and this is your figure 2. Total 4. Okay. Yep. So NumPy is a numerical Python. So something like if you want to create the matrices, if you want to create, arrays, 1-dimensional array, 2-dimensional array, 3-dimensional array. Okay. So basically the machine learning algorithm, it can be work on the matrices format only. Okay. And it should be having the numerical format. So whatever the data we have it, whatever the structure or unstructured, whatever it is, finally, if you want to feed the data to the machine learning algorithm, make sure that the data, it could be numerical Python. Okay, ND format, n-dimensional array format. Okay, I think I can explain you in detail about NumPy, but in this particular situation, you're not at all using NumPy. Okay, we are
Yeah, okay.
just using only matplotlib for this particular example. Okay, so you have already data. This is your list data, same list data. So the difference between, so you can create the data something like this, right? Okay, this is a list Python data structure. But when we have a data something like this, okay, when we have a data something like this, so here what happens, the data, it was, the time processing, the complexity could be more. Okay, it's, when I'm using the numerical Python, the speed of the Python program is little more when you're comparing the normal data structures. Okay, so now I'm using the, NumPy. Without NumPy also, we can creating the 1-dimensional array, okay, with help of the list or tuples, sets, whatever it is. But what happens, the processing speed, it was very less if I'm using the standard data structures of the Python, like list, tuple, those things. But when I'm using the numerical Python data structures like arrays, 1-dimensional array, 2-dimensional array, when I'm using the arrays format, the speed of execution could be better. Okay, and the calculations also, it could be a little speeder when you are using the normal Python. Clear?
Yeah.
So I'm creating the one array. This is my data. This is my series of data. I'm just plotting it up with a histogram. For displaying the histogram, we can have a hist method. Okay, HIST. This is the hist which will be displaying the histogram. So but here 0 to 4, right? So that means this is, it's not a relative frequency table. This is your frequency table, a frequency graph. Title, this is frequency, histogram frequency.
So basically, you can store a list also into a NumPy array.
Yes.
It seems like it, right? Because in this case, you had just had a list. It's not it's a single dimensional list.
It's 1-dimensional list only.
Yeah.
It's 1-dimensional array. Because of we are just giving only one list as an input for the array, so that it's a 1-dimensional array. Okay. If you want, yeah, but regarding about that one, we have to understand the NumPy more. Okay, that is a different concept. It will take at least 1 hour to understanding the NumPy.
Yeah, that's fine.
So, but NumPy is the one of the best library. The main theme of the NumPy and Matplotlib and Pandas are for data processing purpose. Before we do any machine learning algorithms, data should be processed. Okay, for data processing with help of the Python, we have a libraries which are NumPy and Pandas. Okay. For visualization purpose, we have a matplotlib. But in a normally in a other for visualization purpose, we might have the Tableau, you might have the Power BI, right? Same things we can do with help of the Python. Clear? For data processing, we are using either SQL or else Excel, right? For data processing purpose. Okay. Even Tableau also, we have the Tableau prep we are using actually for data processing purpose. So instead of using that things, we have a standard library for Python, which is the Pandas. and NumPy. Clear?
Yeah, we'll go over that as you said, right? I think
Yes.
this.
This is about histogram. Histogram, but here it is not relative frequency. If you want to get the relative frequency, we have to add this term. Okay, see here we see np dot once like, which we are converting into the NumPy. Okay, so I would like to go for display the histogram.
So this plot.show can be a plot.write auto. You can write the output to a file also. The last plt.show that you have at the end, right, which is actually showing the graph.
Yes.
You can write it to a file also, right?
Yeah.
Okay.
Plot show in the sense we're just showing this particular graph.
Yeah. But
Okay.
can you write it to an output file also, right?
Yeah, you can save it. You can save figure. Okay. For example, I would like to save it as the frequency.png. Okay, you can see this graph here.
Yep.
Okay, this is the way you can create the figures. You can save or we can show it. You can, I'm saving as the PNG file format. Okay, now I would like to go for frequency. This is I would like to go for using the relative frequency. Relative frequency in the sense the data, the y variable, it could be probability values 0 to 1 only. Maximum is 1, minimum is 0. So here this graph and this graph both are same or not? This graph is also same thing and this graph also same thing, but it is your relative frequency graph. Relative frequency graph, this is your frequency graph. Okay, so this kind of things we can do with help of the Python as well as R also. R also could be same kind of, it's a very simple thing. Basically this kind of graphs, when we are using, when you are implementing some machine learning algorithms, okay, for understanding the data before we are applying the machine learning, we can do this kind of things. Density curves in the sense, this is your frequency, right? Distributions, creating, interpreting the density curves. So even this here we are getting some kind of curve, right? This is your symmetrically distribution or not. So with help of the density curves, we can understand whether is there any skewness. Skewness in the sense the graph, it was moving in a one side, it was tilted to one side, right, left skewed, and it was right skewed. That means the data, it is not skewed. Okay, no skew in the sense data, it was symmetrically distributed. So the location of the mean and median, it could be it was in a exactly center when it is no skew. But in left skew and right skew, there could be some, then mean is lesser than the median when it is the left skewed. Right skewed in the sense mean is greater than the median values. So this is the things, I think this frequency table only. Here with help of the frequency table only we can display. But by the time the graph, you will be getting exactly symmetrically distributions. Sometimes it was not symmetrically distribution. That means it can be skewed at left side, it can be skewed at right side. Okay. Okay, same thing we can consider it. So here we have 14, I'm taking as the middle value. Okay, so 14 was repeated four times, and 15 is repeated 3 times. Okay. Oh, okay. Okay. 18 is repeated, for example. 14, 14, 10, 15. 2 was 6, huh? This is 5. This is 4. 2, 3 times. 2 times. Let me consider this is only 1 time. Okay. 13, maybe 5 times. 12, 4 times. Intentionally, I'm going to be creating the some kind of symmetric distribution. 8, 2 times. 7, only 1 time. Invalid syntax. Maybe you missed somewhere else. Yes, made a mistake here. See, maybe 7, 8, 9. 7, 8, 9, and 10. 11, 13, 17. See, the distribution was little changing or not? Okay. So this is the way, whatever the data we have it, that particular data we have to be distribute. No, we can make the data into the frequency table. Then by the time or histogram, then we will be getting the graph something like, you know, um, this format. Here some values are not in the, some values are not there, right? It's 17, 18, and it was very high. 19, 19, 19, and maybe you can take the 20 and 20, 21, 20, so like this. Okay. Yes. So this is the way you can display the graph from this particular graph you might able to get this curve format that we are calling it say symmetrically distributed. Okay. Yeah. So anyway, so this is about this kind of graphs we would like to look for it, no? With help of the statistics only we can understand. And in the next class what exactly we will do, whatever the data we have it, so the data we can do some kind of hypothesis testings like t-test, z-test, and chi-square test, ANOVA test, this kind of things, chi-square, these things we will discuss in a next class. Okay, bye guys, see you.